Joel, are you ready for a LunchMAR?
I am. Thank you, Megan, for the introduction. And hi, everybody. Good to meet you all virtually. I'm going to uh, share here. Is that working? Or
Look,
are we still seeing
I'm seeing your screen. Folks,
that?
just as a tip, sometimes the top of your Zoom bar has two different tabs. It says meeting or Joel's screen. Make sure if you don't see Joel's presentation, you have selected Joel's screen. Otherwise, you're looking good, Joel.
Okay. Yeah, I'm seeing you, but it
You're
does
seeing
look like
me?
my screen is sharing, so that's
Okay.
that's fine. Um, all right. So yeah, as Megan mentioned, I'm going to be talking about the Mattole Drought Relief Project, specifically the Vanauken's Ponds Implementation Project. So for this presentation, I'm going to be discussing project background and setting, project design and construction, operations and monitoring, so kind of future, and then lessons learned and kind of applicability to other projects. So a little bit on background location. This project is located in the Mattole River watershed. The Mattole is in northern coastal California, south of Eureka and north of Fort Bragg. You can see in the map here, the Mattole flows from south to north. And this project is located in the Headwaters region. So um, down here. It's Mattole's a little interesting because the headwaters is actually low gradient and really good salmon and steelhead habitat, especially for juvenile rearing. So it's a little different than your typical watershed where you have really high flow or high gradient in the upper watershed. This one's a little bit backwards in that front. Um, our partner on this project was Sanctuary Forest. They're a nonprofit, have been working for multiple decades in the Mattole, and they've been working on the issues of low flow, dry season low flow in particular for the last 23 years. And that work is focused on the headwaters region. So pretty basic. Low flow leads to high mortality of juvenile salmonids in dry years. You can see here a photo of this is the Mattole main stem up towards the headwaters. Disconnected pools. Really kind of non-optimal conditions for salmonids, and oftentimes there are a lot of salmonids in this Mattole main stem and tributaries in the summer. Um, as far as kind of the geology and groundwater dynamics, um, we have generally shallow bedrock, both in the hill slopes and under the channel. So a lot of small perched aquifers. So no big groundwater aquifers in the upper part of the watershed, and even the lower part, is a little different, but nothing, no substantial, managed groundwater aquifers. But groundwater is a key player in how the dry season flows play out every year. So the primary goal of this project was to improve rearing habitat for juvenile salmon and steelhead during the dry season. So really kind of that period of July through October. Some years a little longer, some years a little shorter, but it's the time in our Mediterranean climate where we do not get precipitation. Additional benefits include enhancing riparian forest health and fire resiliency. Kind of creating kind of green corridors or enhancing those corridors. Habitat for other aquatic species, especially amphibians, and then also water security for downstream human communities. In the Vanauken Creek watershed itself, there are no human consumptive uses. It's really managed sustainable forest land, but downstream where after Vanauken flows into the Mattole main stem, you have some human consumptive use on the way down the river. And so just a little bit of background on the flow enhancement strategies that Sanctuary Forest in partnership with Stillwater have implemented over the last several decades. Their program really began with storage and forbearance. You can see here on the right, these are really kind of schematic figures showing how each of these four flow enhancement strategies impacts the hydrograph. So, the unimpaired, again, this is schematic, but unimpaired hydrograph in green and the current impaired hydrograph in black. So, what are those impairments in the Mattole? Really, I think the broad, heavy-handed forestry in the, starting in the 40s and really going to current is probably the largest driver of these kind of this impaired hydrograph. So you have, rather than old growth forests, you have second growth, third growth, a lot of even age management. There is historically been quite a bit of clear cutting in some of these watersheds. And so that results, also the roads associated with that management results in higher runoff rates, and then also a lot more evapotranspiration during the spring and summer months, where those even-aged forests are using a lot more water than old growth forests would have. The human consumptive use as well definitely impacts the base flow here in the dry season. So, straws in the creek and springs. So storage and forbearance, this storage and forbearance is, basically working with individual landowners, providing water storage for them so that they can fill that storage in the wet season and forbear from diverting during the dry season. So you can see the impacts on the hydrograph. It reduces kind of the peak a little bit because that's when they're diverting, and it increases the base flow. This can be substantial in certain water courses, but there's kind of a limitation here. You're not going to drive major change. One area that we're getting into more is forest thinning. And so the idea is, yes, try to address that major land transformation and move things back to toward late seral or old growth type forest. That is a very long-term effort and takes constant maintenance, but we're experimenting with a lot of those types of projects in the Mattole and surrounding watersheds. In theory, those projects should reduce evapotranspiration during the fall. Sorry, yes, during the spring recession and some base flow. So you can see how the treatment here impacts the hydrograph. We've also been experimenting a lot with kind of passive runoff detention projects. So those are smaller unlined ponds that drain kind of naturally, work in stream with beaver dam analog and weirs to reconnect floodplain, and all of those kind of with the goal of groundwater recharge. But what we've seen with those projects is, yes, they fill in the winter, so you get fairly substantial impacts on the peak flow, but the benefits are really most of the times focused on the descending limb of the hydrograph. So our groundwater reservoirs are shallow, the flow paths are short, the porosity is pretty high, and the connectivity is pretty high. So that water, fills up those floodplains or lower hill slopes and drains out very quickly. So then the final strategy, which I'm going to be mostly talking about today, is direct flow augmentation. And so this is, filling up large off-channel reservoirs and, metering that water out when the watershed needs it from a aquatic habitat perspective. So you can see here, more substantial impact on the peak flow, uh, and then more substantial impact here on the base flow. So our most recent flow augmentation project is the Vanauken pond project. Here's a photo of the two ponds that were constructed in 2025. They total 7.8 million gallons of off-stream storage. They are lined with the HDPE liner. These are filled with rainwater only, rainwater and sheet flow. So we don't have a water right for this project. This is an area that gets typically, 80 inches of rain a year. So a lot of precipitation. I think in other areas you have to be a little more likely needs a water right to fill these ponds. And so then water is released from these into Vanauken Creek through infiltration gallery. We'll discuss that more on future slides. This project cost approximately $2.5 million, and it was funded through Department of Water Resources. And the target flow release for this project is around 30 gallons per minute, with some excess water available depending on conditions. So one thing that I think is really that we've done on these projects, there was a lot of pushback from our client, Sanctuary Forest, and other restoration practitioners and agencies as far as trying to really get more longevity out of lined ponds. And so what we have done is we've actually started covering the surface of the liner with gravel. And you can see here on the left, this is actually not the Vanauken pond. This is a smaller 1 million gallon pond in a nearby tributary. And so what this looks like is the pond, you put in the pond liner, you put geotech fabric over it, and then in this case we had a bench cut into the inner berm of the pond, and then filling this upslope with about 6 to 8 inches of gravel on top of the liner. This here is one of the Vanauken Meadow Pond as we were starting to line the top of or put the gravel topper on. So these ponds both have the entire ponds are lined. We use a 1 to 3 inch kind of subangular drain rock, and this is placed again on top of geotech fabric. And in this case, obviously, so far you can't place it with an excavator. So this is placed with a rubber track skid steer. You basically start putting the material on, create a path for yourself, and fill it on out. This was it's a little bit costly and was a little scary the first few times getting out on a liner with a small piece of heavy equipment, but we've done this on multiple ponds now and have not had issues with leakage. So then a little bit on the infrastructure. Obviously, we try to reduce the amount of infrastructure, but in a lot of cases, there's just constraints on the site. In this case, we did not have a good infiltration gallery location that was down gradient from the site, so we needed some way to pump water, not a way uphill, but a little bit uphill. So we have off-grid system, so solar array, battery backup, and inverter. And then we pump water to some holding tanks. And then from the holding tanks, it drains into here our dry well. Would be dry before we put water in it in the spring, late spring, summer, valve and meter. And then we also do include a little security component. For the east pond, this is the second pond, a little bit smaller, gravity is working in our favor on this one. So we have primarily a siphon system that just takes water out of the pond and into the infiltration gallery. But we did want to guarantee that siphon was always functional. So we created this pump assist system. And you can see over here on the right, this is our intake. This is the standard siphon intake, and then this is a pump assist system. And so this pump will turn on basically for a few minutes every day to ensure that the siphon is fully primed and will not fail. Um, so then kind of digging a little bit more into the infiltration gallery, or galleries. So this is, again, the kind of a schematic of the west pond, or the meadow pond. This area here in red is kind of the area where it's collecting sheet flow. Um, and then the red is kind of our water system to deliver water to the infiltration gallery, which is over here, this blue dot. So water is pumped out of the pond over to these two holding tanks and then released via valve and meter into an infiltration gallery at this location. That water will likely spread out across this lower gradient terrace and then enter Vanauken Creek here about 300 to 400 feet downslope. So this is, kind of a little more detail of what that infiltration gallery looks like. Plan view here, just a pretty simple 2-foot diameter cistern with kind of some wings with drain rock. You could see here in the plan, this is more of a section view, but yeah, so the water enters the well and then is able to infiltrate across about a 40 plus foot wide area. And this was we dug down to approximately bedrock, so kind of a fractured sandstone bedrock here at about 20 feet below ground surface. So jumping over to a different project, and really where we got the idea for the Vanauken project is the Marshall Ranch project. And so this is in the Redwood Creek watershed, which is a tributary to the South Fork Eel. In this project, we also have an infiltration gallery. We're releasing about 30 gallons or 40 gallons a minute into that. You can see here the blue dot. And so this is what the water did after we released it. We kind of had two primary flow paths, but the water really spread out across a pretty broad terrace along the bedrock interface and provided kind of this, I would say, non-point source flow enhancement benefit to Redwood Creek. So we're expecting the same sort of spreading of the water at Vanauken. We have a similar geology as far as depth to bedrock and soil type. So pond monitoring, this is pretty simple, but we do have data loggers in the pond. They are sitting on a similar crab pot system to our other primary outflow intake. You can see someone in the project was an ocean person. These are the modified crab pots. And then one thing I just wanted to mention is really one of the key kind of regulatory pieces of this is ensuring that these ponds don't become inhabited with bullfrog, which are invasive species. And so far we have not had any issues. The fact that these are don't have a lot of vegetation around the outside and are drained down really heavy every year does not provide very good bullfrog habitat. And then as far as just kind of operations, each of these ponds we've developed a stage discharge relationship so we can, see how much volume is left in the pond in real time by downloading the data off these loggers and comparing them to this table, and you can see how much water is left for planning and operations purposes. In-stream flow monitoring is a key component of these projects. So especially water temperature, dissolved oxygen, and stream flow, upstream and downstream from the point of flow release. And just kind of touching on some other project results. This is a photo from a nearby tributary in the Mattole, much smaller than Vanauken Creek, but similar setting and similar impacts. And so these photos compare conditions in early October in 2016 and 2024. These were practically identical water years. Um, we were very lucky to have pre-project data from quite a while ago that had a water year that was such a good comparison. And you can see, it's only a few gallons a minute, 3 to 4 gallons a minute, but it just transforms this creek from really a dry gravel bed. You can see, I think, a little, pool here, but into a flowing creek where you can imagine the fish and other aquatic species would be thriving in comparison to this photo on the left. And then some additional monitoring data from the Marshall Ranch project, which again is uh, it's really just to the west, or sorry, just to the east of the Mattole in the South Fork Eel watershed in the Redwood Creek tributary. And this project here, Marshall Ranch project, is about 5.5 miles upstream from the confluence with the South Fork Eel. So we're really looking to improve habitat throughout that 5.5 miles with approximately 50 gallons a minute of 40 to 50 gallons a minute of flow augmentation. We've run that project for 2 years now, and it's going quite well. Um, this is some of the data from our first year of operations. You can see this upper graphic. The three upstream gauges all go dry at some point during the summer, and all of the downstream gauges all maintain flow. Although it gets really low, they do maintain flow. Um, Looking at just one of those downstream gauges, this is the one closest to the project here on the bottom, RC 1.8. And you can see that, during the 6 years of monitoring data, 2024, so our post flow augmentation was the only year where flow was maintained throughout the summer, even though we had this one actually really wet year, 2019. So it was going this station was going dry even in quite wet water years, but and our project reversed that trend. So that's just some high level kind of like flow data, but then looking at temperature benefits specifically of the infiltration gallery. So what are those benefits of utilizing hyporheic flow and groundwater recharge? And so here on the right, you can see this upper line here that's our pond water temperature at depth. So at approximately the depth that we were extracting that water, the water was really warm. So 75, even up to 80 at this peak, and then really ranging between 72 and 80 throughout our release period. And then this red line here at the bottom was the water being released from one of those primary hyporheic flow paths that we were able to measure. As I mentioned, a lot of it was kind of dispersed and not super easy to measure, but this was a spot where we could measure it. And you could see just a substantial cooling benefit. So that was really a positive outcome, and led us to uh, ensure that these sort of flow release uh, features were built into all future projects of this type. Um, the dissolved oxygen question is a little more challenging, or a little more nuanced. And so, what we found is that, the groundwater, releasing water through an infiltration gallery, does moderate DO or bring it down below kind of what would be optimal for salmonids. And so, here in this graphic, the green is actually the water being the pond water. So it's a pretty windy location, so pretty aerated. We also did have we do have the ability to aerate those ponds. So generally pretty high DO, except for this one spot here. The light blue is actually our downstream measurements in Redwood Creek. So this is kind of downstream from our flow release. And then the dark blue and the orange are the water coming out of the ground. So these are kind of the two different places where we can measure the DO in our flow release, flow augmentation, before it gets to Redwood Creek. So you can see that those are, they're around, especially the French drain here is around 4, which is, it's not lethal, but it's a little lower. I think the target is usually for salmonids is 5, above 5 is ideal. So that's something to watch. Then this purple, on the other hand, is actually in Redwood Creek upstream of our project. So this is basically where there is disconnected flow, no connectivity between the riffles or between the pools across the riffles, and so you can see like fairly lethal level DO, at least at this monitoring point upstream. So then, one last piece of kind of like how these projects are working. We did do snorkel surveys for the Marshall Ranch project. The project flow release here is in blue, and this is the downstream or impact pools. So we monitored fish presence in these pools in across 2 different survey efforts. So one in late July, and so that's really when conditions are just starting to dry up, but before the flow becomes disconnected upstream. And then one second survey period in the control period, which is in the control reach, which is upstream. Oh, sorry. A second monitoring date in September, which is the driest period. So impact and control, and then kind of, pre-flow augmentation benefit and post-flow augmentation benefit. And what you see here is, some a pretty strong correlation between the salmon survival in the impact reach or downstream of the project and the control reach upstream of the project. Now this is we're digging into this more in 2026 for looking at we're hoping to do some pit tagging and look at a little bit at movement and health of those fish. So summary and lessons learned. I would say that overall, flow augmentation projects are successfully achieving objectives. We have just seen significant improvement in the aquatic habitat conditions in these reaches. This small amount of flow is providing benefit. It's not disappearing. It's providing meaningful benefit significantly downstream. Including the groundwater recharge component is really proving to have substantial temperature benefits, reducing the temperatures of the outflows to levels that are suitable for salmonids. We do have kind of this challenge of balancing water temperature and DO. So when we release more water, sometimes we can actually kind of overwhelm our infiltration galleries and get some surface flow connectivity, which can actually increase DO because you have surface flow, which is good for Coho, but that can also increase the water temperature. So because you're basically have the warmer pond water going directly into the creek. So there's kind of this balancing act. And then that is also there's just that that trade-off at the project site itself, but then you also have considerations of the downstream reach. So as you go downstream, maybe there's a little more evapotranspiration, more consumptive use, And so, but maybe there's an important fish population downstream. So being able to release more would be good, but then you maybe have some impacts at the site. And so it's really kind of a juggle in terms of operations, and we're constantly adapting and looking for collecting additional data and looking to optimize our operations. And that just kind of highlights this last bullet here, which is these types of projects need ongoing operations. So they need to be someone needs to be involved, and then adapting them to basically optimize for the objectives. So I think with that, that was my last slide, and so looks like we have a bit of time here for questions. I see David. Oh no, just claps.
I'll throw out a question. Oh.
Hey, Michael.
Hey, Jill. What kind of like scale do you see this particular treatment applied at? Like if you were to do it in other portions of a system?
Yeah, I mean, I think it could be applied at various scales. I think the big there are certainly constraints, and so I would say that obviously with any project, cost is a constraint, and so bigger, you're just going to have a lot of cost in earth moving and um, liner cost, etc. Um, Beyond that, I think constraints related to just suitability. So places where you can build a large storage reservoir, and then places where you have kind of space to, infiltrate water and achieve that benefit. Obviously, similar to storage, where the more storage you have, the more space you need. Um, I think the same could be said for infiltration. So the more water you want to infiltrate and cool, the more space you need to do that. And then I would say the last constraint would really be, the supply, the water supply. Um, so being able to fill in the wet season. And so that's, obviously where we're working in the North Coast, there's, a lot of water, even in drought years, you know, 40 inches of rain typically. And so, really, I would say those would be the three kind of main constraints. Um, but I think the general approach could be applied in a lot of different settings. I think there was a couple other questions.
Hi, thanks for the presentation. Really interesting work. And I was wondering if in your monitoring and measurements, um, that if you had noticed or measured how much water is kind of lost in translation between, moving it through the groundwater infiltration galleries, and then it, entering the stream flow. What's kind of the efficiency factor there of the water moving from the pond into the stream?
Yeah, that's a great question. It's a hard one to measure because our stream itself also has a significant and variable hyporheic flow component, through the gravels. So, our upstream and downstream monitoring stations are you know have kind of varying degrees of subsurface flow at them. What I would say is that this it takes us, there's a substantial amount of water lost at the beginning of the year to basically um, wet the system. And so, you know, when we start to release flow, we we see kind of the first signature of that flow coming out, after about 18, 24 hours. And then, over the first really week and a half, 2 weeks, it starts to kind of wet that whole fan. And so this is kind of my experience at the Marshall Ranch project. And so I would suspect that during um, that period of wetting, that we were, losing a substantial amount of water to basically just kind of moistening and filling the voids in the ground. After the system is fully saturated, it's actually quite responsive. And so when we adjust our rates of input, we see like a pretty responsive outputs. And so I really don't think that once, that there's a substantial loss. I'm sure that's in the, 5 to 10% range just by, additional evapotranspiration, kind of additional, kind of expanding of that wetted soil even beyond that initial 2 week period. But we really don't see, we really see most of our inputs in the downstream flow measurements. So we're also in a geology that's like our bedrock is pretty impervious. It's like a shale stone, and so that we have that working for us. And then just kind of the setting is everything is kind of the bedrock surfaces are all sloping toward the creek, so there's no big sinks anywhere.
Hi, this is David Ferriman, hydrogeologist, and one of the things, I've thought a lot about using dry wells and infiltration galleries to as a method to get water in the ground. And the thing that always comes up is the clogging. What were your considerations? Did you do anything to try to prevent that? And kind of what do you think the useful lifetime of these are going to be?
Yeah, I mean, I think one of the things that you know, the advantages of this approach as opposed to kind of like actually putting kind of storm water directly into these types of wells is that, these ponds are pretty, especially by the time we release water, they're pretty clear, not a lot of turbidity. So it is really, we're putting kind of clear, clean water into these wells. So, we're really uh, anticipating that they're going to work for a while. The one of them, the Marshall Ranch is a little more, it's actually a little more challenging. It's because it's located in a small tributary that is, bringing in some fines every year. And so we anticipate that one, may have some clogging issues over time. The one on Sanctuary Forest on the Vanauken project, yeah, what we really tried to do there was just build a really big that kind of 40-foot wide with a 5 foot wide by 5 foot deep basically leach field type system. And just even if it starts to clog a little bit over time, hope that a little bit of extra pressure head that we can get on it through that through the well would help push more water. I think ultimately these projects, even if we do have some surface water, if these infiltration galleries clog over time and we start to get some surface water flow, um, or more surface water flow. I think that's gonna be fine. Yes, it's a little bit warm, but really what we've seen with the DO dynamics is that a little bit of surface water actually kind of offsets the low DO coming out of the groundwater, and so it's not a bad thing. I think right now in the initial phases of this, these initial kind of pilot projects, CDFW is very concerned about fish and particularly coho and warmer water, and so that's why we're really focusing on collecting data on fish use, especially in the close proximity of some of these flow releases, to understand you know how the fish are using them, how they're impacted by a little bit warmer water versus colder water with low DOs, what their yeah, what the drivers are there to try to, gain a little flexibility moving forward on kind of that temperature issue. But yeah, I think overall our releases are fairly small, and so we do expect these infiltration galleries to work fairly well over time. Any other questions? I think one thing I can talk about a little bit more that I left out of my presentation on purpose is permitting. And so, I would say it's variable depending on the setting. And so, the Vanauken project, because we are, uh, you know, really off stream, we don't have any diversions. Our flow releases are directly into infiltration galleries that are off stream. So that project really, the main focus was, you know, CEQA and a grading permit. And for the other project that I showed, the Marshall Ranch, that had more of the normal gambit of permits, including an appropriative water right and non-point source uh, or a MPDS waste discharge permit, and then typical LSAA 401, et cetera. So I think, yeah, it was, we've worked really closely with agencies on these projects from the inception to kind of understand permitting pathways, et cetera. And I will say that, they are a little bit unique. And so there have been some, in some cases, I would say, a little bit of misdirection at times as we kind of navigated that. What permits were needed, who lead CEQA agencies, et cetera. So, yeah, that's definitely been there's been some interesting conversations and discussions on that. But I think overall, uh, it, it hasn't been too bad. Anyone else?
I'll jump in here because I don't know if Megan is occupied at the moment, our network coordinator. Usually she does say a few words here at the end to sort of thank everybody for coming if there's no more questions. Any other fun happenings in the world of LunchMAR that anyone wants to share about? Events coming up. Otherwise, we can send you all on your way. Really appreciate your presentation today, Joel.
Thank you.
Thank you, Joel.
Awesome.
Thanks, everyone.
Thank you, everybody. Really appreciate it. Take care, and we'll see you next month.